Good evening. I apologize for any shaking in the video. I'm using a mobile device, so it's pretty hard to keep steady. Today I'm going to be explaining to you the chain rule of calculus. The theorem of the chain rule of calculus is for a composition function, f of gx, its derivative is going to equal the derivative of the outer function, which is f of gx, times the derivative of the inner function, which is g of x. So to make it simpler, I'm going to do an example. Let's say 2x plus 1 cubed. Let's say this is our f of gx. Now, what would its derivative be? Well, first of all, we got to know what the outer function is. Well, the outer function is actually the entire function, 2x plus 1 to the third. So I'm going to just write it here, even though it's stated here. Now, our inner function is going to be what's inside here. This is going to be our inner function, gx. So we're going to write it here. Gx equals 2x plus 1. Now, we gotta know, to find out the derivative of the entire function, we gotta multiply the derivative of this function times the derivative of the inner function, which is gx. So, what would our f of gx derivative be? Well, we can actually treat this as an exponent function because of the exponent. So, the way we're gonna approach this is similar to how we approach x to the 3. Now, x to the 3, you know that when you're differentiating, you take the exponent and you multiply it by the coefficient, which in this case is just 1. So it'd be 3x, and then you subtract 1 from the original exponent, which equals 2. So x to the third, its the derivative would be 3x2. So the same way we're going to approach this problem. 2x plus 1 to the 3, its derivative would just equal 3, because we take the exponent and put it here, times the coefficient, which is 1, times the f of x, which we're not going to touch yet, elevated to 2, because we're going to subtract 1 from here, same way we did here. So it's going to equal 3 times 2x plus 1 squared. Now, this is our outer function. Now we got to multiply it by our inner function. Our inner function is gx. So what is the derivative of 2x plus 1? Well, you know, for a derivative, a linear function such as this, you take the coefficient multiplied by the derivative of the constant. In any case, any constant derivative would be 0. So this would just equal 2. So here is going to be 3 times 2x plus 1 squared multiplied by, yes, you guessed it, 2. And this whole thing would equal 6 times 2x plus 1 squared. Now this is the derivative of the f gx. Now, our problem for today states that let f and g be differentiable functions to satisfy the following. F of 2 is going to equal 5. Then the derivative of g of 5 is going to equal -3. And the derivative of f2 is going to equal 7. Now, we don't know what f of x is, or its derivative, and we don't know what g of x is, or its derivative. We only know that at the given value, at the given x, 2, 5, and 2, we're going to get these values. Now, the problem is h equals g of fx2 is a composition function, where gx is going to be the outer function and fx is going to be the inner function. Now, we need to find out what the derivative of h at 2 equals. Now, we know that h equals a composition function, so its derivative is going to be the same as our theorem. Is going to be the outer function derivative, which is g of f of x, multiplied by our inner function derivative, which is f of x, f prime x. So now, all we have to do is substitute our x, which is 2, in the chain rule theorem. Now, g prime of f2 multiplied by the derivative of f at 2. How do we know what these mean? Well, they're givens. f2 equals 5. So we substitute this f2 for a 5. So it's going to be g prime of 5 multiplied by the derivative of f2, which we know is 7. So just multiply it by 7. And it's also given the g prime of 5, which equals -3. So it's really as simple as -3 multiplied by 7, which we all know equals -21. So the derivative of h at 2 equals -21. How? Because we substituted the value for 2 here in the chain rule theorem, knowing that h is a composition function. And because all of our values were given already in the problem, we could just substitute these values in a step-by-step process to give us our final derivative. So for every composition function, this process can follow if you have only the values and not the entire functions for it. But even if you do have the entire functions, we can still do this process. So that basically is chain rule in a nutshell. I hope you could understand from this video the step-by-step process. I hope that you learn a lot from this video. My name is Carmel Huertas, and thank you very much.